Okay, here's warm-up number 18. I'm going to do a two-column proof here, and I have it splitting into two different paths because there's two different ways that you can finish this proof. So I just want to illustrate both of those different methods. Okay, so I've got angle 2 and angle 5 are supplementary. That's my given information, these two angles, okay? And that's in the proof already, and the reason is given because it's just a given info. Okay, and then next up it says that angles 1 and 2 are supplementary. The only way to figure that out is by realizing that you've got a linear pair up there. Those two angles fit together perfectly to form a straight line. They're adjacent to each other and they're a linear pair. So this is the linear pair postulate that says that angles that form a linear pair are supplementary. Okay, and let's do this left path first. It's a little bit quicker of a path, shorter path. So from there, we want to say that angles 1 and 5 are congruent. A lot of times I'll see people say, oh, those are corresponding angles, so they're congruent because of the corresponding angles theorem. But you can only do that if the tracks are parallel. And I don't know that the tracks are parallel yet. In fact, that's what I'm trying to prove. This is a lowercase cursive L, by the way. I get asked that a lot. Okay, so yeah, I can't use corresponding angles because the tracks aren't marked as parallel, or it's not told that they're parallel in the given info. Okay, so I have to do something else. Here's what I'm going to do. If you look at the first two statements, both angle 5 and angle 1 are going to be supplementary to angle 2. And so let's say that, angle 2 is 100 degrees. Okay, so if both of these are 100 degrees, then both of these would have to be 80 degrees, right, to get to 180, which means that those two would be congruent to each other. So these two angles are going to be congruent to each other just because they're supplementary to the same angle, okay? Sometimes people will say, oh, that's transitive. But transitive is when you have two things equal to each other, to the same thing, so they're equal to each other, or congruent to the same thing, so they're congruent to each other. But here we have two things that are supplementary to the same thing, and that makes them congruent to each other. So this is called the congruent supplements theorem. I don't have a lot of space here, so congruent supplements theorem. Doing some abbreviating to get that in there. Congruent supplements theorem is what I use there. Now that I have these two angles congruent, now I can say, oh, if those two corresponding angles are congruent, then the tracks have to be parallel. This is actually the converse of the corresponding angles theorem. Corresponding angles theorem would be if you knew the tracks were parallel to begin with. So this is the converse of that. I'm going to write it down here just because I didn't leave space. So this is the converse of the corresponding angles theorem. Okay? All right, so let's try this other path. Let's say you forgot about the congruent supplements theorem and you're kind of stuck. There's a way you can get around it. Another way you could think of this, here we've got two things that are equal to 180 degrees. So that means those two things must be equal to each other. And those two things are the left side of both of those equations. So, measure of angle 2 plus measure of angle 5 would equal measure of angle 1 plus the measure of angle 2. So I can use the transitive property or substitution. It's just that doesn't get you straight to this. That gets you to this. So transitive or substitution, you don't need them both, but either one would work here. Okay? And now getting from step C to step D, those equations are pretty similar. The difference is that the step D doesn't have the measure of angle 2. But if you subtract the measure of angle 2 from both sides of step C, then that'll put you there. So the subtraction property of equality will get you to that next step. Okay? Subtraction property of equality. That's when you're subtracting the same thing from both sides of an equation. Okay? And now, just like before, when we've got those two congruent, then the tracks have to be parallel. So we're going to finish this with the converse of corresponding angles once again. Okay, did a little abbreviating there because I got it written right here too. Okay, so next problem. If angles 1 and 8 are congruent, so let's mark them as congruent, which lines must be parallel? So it looks like these two are parallel. It looks like those two are parallel, but we don't want to go based on looks. Let's go based on given info. So here's how I like to think of these. I like to think of the segments that form the congruent angles. So like angle 8 is formed by, I said segments, but these, I mean, that's array. I guess this is array as well. Okay, so those pieces are forming that angle. And then let's look at angle 1. It's this piece and this piece. Okay? So I like to think of those as kind of the angles are gluing those highlighted rays in place, those highlighted lines or rays, however you want to think of it. Okay, but L is kind of a free agent. Okay, so it looks like it's parallel right now, but I could kind of swivel this like so, and now it doesn't look parallel anymore. But it's not going to change the measure of those two angles, right? Those two are glued in place. So I can swivel this one around and make it not parallel. So maybe these lines are parallel, maybe they're not, but I don't know based on the given information, okay? R and S are going to be parallel. They're rigid, they're glued in place. I can't swivel them around. And then also, hey, these are corresponding angles formed by those two tracks. So when these corresponding angles are congruent, the tracks are parallel. So R and S are the two that have to be parallel here. And my justification just means which theorem. We're using the converse of corresponding angles theorem again. So used it in all three of these problems. Well, all three if you count those two as two different ones. But yeah, converse of corresponding angles once again. Okay, and that's the end of the warm-up, and I'll see you next time.